So on this video, we're going to be talking about how to calculate the gradient of a straight line on a graph. Remember to use the pause button and the rewind button if you want to look at anything again or try anything out, and bring any questions you have to the lesson. So the first thing you need to do here on this straight line graph is you have to pick 2 points. So I've picked 1 point here, I picked 1 point here. You can see that I've put them on the graph lines so that later on our calculations will be simpler. So here are my 2 points, and the further apart they are along the line, the better. So now that we've got these 2 points that we've put in, the next stage is to draw 2 lines across and down from the points and make sure they're long enough to cross over. So here you can see I've done a dashed line down, all the way down to here, and here I've done a dashed line across, and then they're crossing over at this point here. Okay, so the next step, we need to use the scale on the y-axis and the scale on the x-axis to work out the value between the line of best fit and the point where they cross. So by that I mean we're going to try and work out the value from here down to here, so that value on the y-axis scale, and we're going to work out the value from here over to here, this value on this x-axis scale. So let's have a little look at how we do that. So let's do the y change here on the y-axis. So we find out this is the point where the 2 lines cross over that we drew earlier. If I follow this along, that value there is 3.0, that's 3 ohms. And then if I have a little look up here, what's the value on the y-axis of this point? I go across, this value here is 10.0 ohms. So if I do 10 ohms minus 3 ohms, that's where this one was, I get 7 ohms. So the value of this change here is 7 ohms. And when we refer to that, when we're going to write it in a minute, we're going to call that delta y. So that's the value of the change in y, 7 ohms. We're going to do the same thing for the x-axis. So we need the value of this point here. So here's the point, we go down, read off the value, that's going to be 0.5 centimetres. And then we're going to go down from here. Here's the point where they cross over, take that down, or I'm putting 3 on the scale. That's going to be 7.5 centimetres. So we're going to do 7.5 minus 0.5, and that's going to equal 7 centimetres. So this one here has got a value of 7 ohms, and this one here has got a value of 7 centimetres. And this 7 centimetres, we refer to that as delta x, because that's the change in the x-axis value. So here you can see we've got delta y is equal to 7 ohms, delta x is equal to 7 centimetres. To calculate the gradient of the line, I'm going to use this equation here, which says it's delta y divided by delta x. So that's the change in the y value divided by the change in the x value. I mean, it has to be that way around. You have to have delta y divided by delta x. So if I do that sum here, you can see I've got 7 divided by 7, and that equals 1. So my gradient has a value of 1. But what I can do, and we're going to be doing this a lot when we find the gradient in physics, we need to put units, if possible, on that gradient. So this is 1 ohm per centimetre. So that's it. That's how we calculate the gradient of a straight line. It's a couple of things to be really aware of. Always make sure you're turning the squares. So you're going to count the number of squares, but you're going to turn that into a value according to the scale on your graph on each different axis. Remember that it has to be delta y divided by delta x. And remember, wherever possible in physics, to put the units of the gradient in as well, because that allows us to calculate other things.